All right, welcome to problems 11 and 12. So these problems are about graphing. So if you are like many students right now, you are thinking, holy smokes, I do not remember this at all. I would recommend starting by looking over your Unit 3 note packets or any Unit 3 materials that you may have because it's a lot to go from remembering nothing to doing these more challenging problems. So I would refresh your memory first by checking your notes and reviewing things like amplitude. Amplitude is the vertical distance that your graph is covering, half of the vertical distance. And things like b, right? Hopefully you remember 2 pi divided by b, that's our period. Horizontal shift, vertical shift, all of those things. I'll try to review as much as I can, but it's kind of a lot to take in. So I, again, really recommend looking back at your Unit 3 materials. With that, let's get started. So 11 wants us to graph. It also wants us to give the period, the amplitude, the shifts, the domain, and the range. So let's start with our period. So to calculate period, you want to first look for your b value. So in this example, our b is 2, and therefore, when I'm finding my period, I'm going to be doing 2 pi divided by 2. And the period for sine or cosine is typically 2 pi in radians, or 360 in degrees. So for sine and cosine, you'll do 2 pi divided by 2. For tangent and cotangent, the typical period is pi. So your numerator will just be pi there. But in this case, our period comes out to be pi radians. Our amplitude is this number right out front. So that's going to be a 3. Our shifts, none. X is not being added or subtracting, right? And there's no plus anything on the end, so there's no shifts. There's no plus or minus anything. Domain for sine and cosine, hopefully it makes sense. Don't our sine and cosines just kind of go on and on forever like this? So the x values that they're covering is going to be all real numbers. The range, and maybe you want to graph this before you answer this question, but typically my range for sine is from -1 to 1. But in this case, since it's my amplitude is 3, my range would be -3 to 3. Awesome, let's get graphing now. So my amplitude is 3, so that means I'm going to go up to 3 and down to -3. I know that my period is pi, and since there's no shifts left or right, I can put my last marking as pi. Now to get our subintervals, some of us can do this pretty nicely by hand. I'm going to show the long way just in case though. You multiply your period by our quarters, right, our subintervals. And this is pretty easy, right? 0 times pi is just 0. 1/4 times pi is just pi over 4. So on and so forth. First one 0. All right, so those are our subintervals, and now it looks like we're ready to graph. So sine starts in the middle. Sine soars. It goes up first, then back in the middle, then down here, and ends right where it started. And remember, sine and cosine should always end where it started, right? Just when we add the period, we should be back to where we started from. So your graph should look a little something like this. Beautiful. Looks pretty good. And if you didn't really see where the range is coming from, hopefully now you do, right? The biggest it's getting is 3, and the smallest it's getting is -3. let's move on to something a little bit trickier here. In part B, again, I need my period. In this case, there's nothing being multiplied by my x, so my period is going to remain the typical period of 2 pi. My amplitude, there's nothing, no number out here, so I guess there's a floating 1, amplitude of 1. My shifts, looks like I'm going left pi up 2. And my domain and range. So my domain is always all reals for sine and cosine. And for range, so let's think about this. Typically my range is from -1 to 1. But since I'm adding 2 at the end there, it will be from 1 to 3. If you wanted to write that in brackets like that. 1 to 3. Awesome, let's get started. So remember when we were doing this, we all had different ideas about how to best graph these. Some people like to reassign, some people like to keep it. Just for the sake of space, I'm going to reassign everything, but I hope you remember from this unit, your graph can look a little bit different depending on how you label your axes. So if your graph doesn't look exactly like mine, it's possible we just went about it in 2 different ways. And I would encourage you to check your graph with Desmos and make sure all the key points are the same and whatnot. Because it's possible your graph is correct without looking exactly like mine. So what I mean by that is I'm shifting to the left, oops, I forgot a T there, left pi. So that means my start is at -pi. Now I'm reassigning my origin, my start point is -pi, but some people might put -pi over here, which is definitely still correct. Just depends on how you assign your axes. I'm going to choose to reassign my origin as -pi. And from 1 to 3. So I'm actually going to assign this as 1 and this as 3, just to give myself a little bit more room, especially because I'm on the smart board. So that means in the middle here is going to be a 2, right? 1, 2, 3. Awesome. Now let's think about my subintervals. So we do 0, 1/4, 1/2, 3/4, and 1. And we're multiplying it by our period. So these are our typical subintervals. So this shouldn't be too surprising. Two pi over 4. Yep, so you can look on your unit circles for those as well. And now I am subtracting pi. So my start point is -pi. Pi over 2 minus pi, that is going to be -pi over 2. Pi minus pi, that's going to be 0. 3 pi over 2 minus pi, that's 1.5 pi minus 1 pi. So that's going to be pi over 2. Hopefully this makes sense symmetrically, right? And then last but not least, 2 pi minus pi, that's an easy one, right? 2 pi minus pi, that just gives me pi. Awesome, so let's make sure here. I shifted left pi and moved up 2. Let's get to graphing now. So it's a cosine. Cosine starts up. Cosine crashes, so it's going down first, and then again, it should end right where it begins. So let's fill this in, and there it is. And just as a reminder, it keeps going, right? I just ask that you graph one period, but keeps going forever and ever. Awesome. All right. Ooh, tangent. I don't wanna. Just kidding, we can do it. All right, So this is a little bit different world now, right? We're not in the world of 2 pi period. We're in the period of pi. So starting off with the period, there's no b, so it's just a regular old pi. Let's look at our amplitude. It's 3, right? 3 is out front. Shifts. Looks like I'm moving right pi over 2. Hopefully we remember that our horizontal shifts are always the opposite. So if I'm minusing pi over 2, that means I'm going to the right pi over 2. But our vertical shifts are not opposite, so that means up 1. Awesome. All right, here's the tricky part. Domain and range. So tangent is a little bit different. Hopefully you remember that actually there are asymptotes, which is going to kind of mess up our domain a little bit here. I'm going to come back to our domain and range. I would recommend that you graph first and then think about domain and range to make things easier. So that's the strategy I'd like to take. I also want to take a moment to review that our general tangent shape looks like this with an asymptote in between. So yes, you do need to draw your asymptote, of course. Let's get going here. Again, I'd like to reassign my axes just in the honor of space. I don't have that much space on here. So this is pi over 2. My period is pi. So I really only need, my beginning, middle, and end for a tangent. So let's multiply this out. Now if you get all your subintervals again, that's fine. But since my period is shorter, I don't need all those subintervals. So 0 plus pi over 2, that's my start point. My middle is going to be pi over 2 plus pi over 2. That's just pi. Pi plus pi over 2. You want to get a little common denominator here. Looks like that's going to be 3 pi over 2. So I'm going to make this 3 pi over 2, and this pi. Awesome. So again, that's my general shape there. I next need to figure out this plus 1 situation. So typically, my range, or not my range, but my important values of tangent are from 1 to 1. But now they're from -3 to 3, and then adding 1, so let's write that down here. -3 to 3, so then if I were to add 1, that's going to be -2 to 4. So that means my middle is going to be a 1, correct? My amplitude is 3, so between these two values should be 3. Between these two values should be 3 units. And that's all checking out. So that's good. So this is 2, this is -1. Awesome, so let's get going here. I'm going to mark my point there. My asymptote then is in the middle. So I'm going to have an asymptote at pi. And I'm going to just do a little swoop and swoop. Beautiful. So now let's come back to our domain and range. So you can imagine this graph is going to keep going, right, with asymptotes after that. So let's see, domain, where are all of my asymptotes going to be? It looks like they're all going to be at multiples of pi. So you can think, imagine where your first asymptote is. So domain is all reals, except x cannot be pi, right? That's my first asymptote. And then it looks like plus my period, plus pi k, right? It's at every asymptote, and then if I add multiples of my period, there's going to be another asymptote. So it's all real numbers except for x is obviously not existing at these places here. For my range, it's going to be all reals, right? Tangent's going